A couple of days ago, this post on Hacker News caught my eye. A fintech company completely replaced their expensive specialized OCR vendor with Google's Gemini to process PDFs. The results were astonishing. Processing time plummeted from 12 minutes to just 6 seconds, accuracy soared, and they slashed their costs. This isn't just an improvement, it's a game changer. It's another example of how LLMs are making specialized SaaS products obsolete overnight. We are really talking about a potential SaaS killer here. And in this video, I'll show you how to build your own version of this solution. A powerful, automated PDF processing pipeline using Gemini and Google Cloud Services. So, what are we actually building? We want to build a fully automated system that takes any PDF you give it, extracts the text and data with incredible accuracy, and stores it in a structured format. This pipeline could then be used to, for example, instantly extract invoice details like amounts, dates, and vendor names to automate your accounts payable process. You just upload a document, some magic happens, and 5 seconds later, the key information is ready to use. No manual processing, no expensive software. That's the pipeline we want to build. Now let's check out the architecture and see how this magic is actually made possible. It's surprisingly straightforward, thanks to some of GCP's serverless services. Here is the detailed flow. It all starts when you upload a PDF to a Google Cloud Storage bucket. This upload automatically generates an event. EventArc, using PubSub behind the scenes, captures this event and prepares to route it. EventArc then delivers the event, triggering our cloud function. This is where the core processing logic lives. The cloud function retrieves the PDF from the bucket and sends it to Gemini for intelligent data extraction. This is our OCR replacement. Finally, the cloud function takes the structured JSON output from Gemini and stores it in Firestore, our NoSQL database of choice. And, believe it or not, that is already the complete pipeline. A simple, serverless, and incredibly powerful solution that can be adapted to a wide range of use cases. Setting up this architecture doesn't take much longer than drafting it. First, we need a place to store our PDFs. Therefore, let's quickly create a Google Cloud Storage bucket. I'm in the Cloud Storage section of the console. I'll click Create Bucket, name it PDF Bucket 456, and choose a multi-region and close to me for best performance. The other settings, I'll leave at the defaults for now. And finally, I'll click Create. Okay, our bucket is ready, now we can write our cloud function. I've already got the core of it here. It's surprisingly straightforward, so let's break it down. First, we get the details of the uploaded file from the event, the bucket name and the file name. This tells us which PDF to process. Next, we create a so-called part object that references the PDF in GCS. We send this object to Gemini with a simple instruction. OCR this document and output JSON with relevant fields. Gemini then does all the heavy lifting of OCR and text extraction, returning structured data that we pass from the response. Finally, we take that structured JSON data from Gemini and store it in Firestore. Now let's deploy this. In the Cloud Run Functions section of the console, we will create a new function. I'll call it Handle PDF. Choose a region close to me and select Python 3.12 as the runtime. The key here is the trigger. We are choosing cloud storage and setting it to trigger when a file is finalized in our PDF bucket. That's how the automation is made possible. We can skip over the remaining settings, leaving them at their default, but I want to give a quick note on service accounts. This cloud function needs permissions to access other services. You will want to give the service account associated with this function the minimum permissions it needs to read from storage, write to Firestore, and use the Gemini API. Google Cloud will usually guide you if you're missing something. After this basic setup, we copy-paste our code, update the entry point, adjust the dependencies, and redeploy the function. It might take a minute or two to get it ready. Great, our function is deployed, but it's not at all clear how this happened. Therefore, let's take a peek behind the curtain to understand such a deployment in more detail. When you deploy a cloud function, it's not just storing your code. It's a whole orchestrated process. First, there's the build. Your code and dependencies get bundled up and sent to Cloud Build. Think of Cloud Build as a factory that takes your raw materials and creates a ready-to-run package. It uses something called a build pack, basically a set of instructions, to create a container image. This image contains everything your function needs: a lightweight operating system, the Python runtime, your code, and all your dependencies. This image is then stored in Artifact Registry, another Google Cloud service. Next up, we have the deployment. Cloud Run, the engine behind Cloud Functions, grabs the container image, creates a new revision of your function, sets up an HTTPS endpoint, and gets it ready to receive requests. Besides the function, we also deploy the trigger, the mechanism by which an upload actually calls our function. And that is where EventArc comes in. EventArc acts like a smart router for events. When you deploy it, it automatically sets up a connection between your cloud storage bucket and your cloud function. Behind the scenes, EventArc uses PubSub. So the flow is, your PDF upload creates an event in cloud storage, which gets published to a PubSub topic. EventArc, listening to that topic, grabs the event and delivers it to your cloud function. PubSub makes sure the event gets delivered reliably, even if there are glitches. It's a powerful, resilient system, and the best part is you don't have to manage any of it. Finally, we have the execution. When a request comes in, triggered by our file upload, Cloud Run spins up a container instance from the image. The functions framework, a lightweight web server, calls our Python code, the function does its magic and sends back the result. Now let's see this in action. I'm in my PDF bucket, and I'll upload a sample PDF. It could be an invoice, a contract, anything. In the background, our function is now being triggered and the file being processed by Gemini. When we now switch to Firestore, open the default dataset and inspect the only document in there, we can see our data, extracted and structured by Gemini. So there you have it. We took inspiration from a real-world success story and built our own PDF processing pipeline. We use Gemini and Google Cloud Serverless services to create something faster, cheaper, and more flexible than traditional OCR solutions. And we did all that within a couple of minutes.